Well, hello guys, and welcome back to Mr. G Physics, the channel that is going to help you to improve your marks in physical sciences. Here's Mr. G, and today we're going to be solving a question for the grade 11 and grade 12 on electrostatic. It's a very important topic. But before we move on, don't forget to subscribe so you can get all the notification and videos I post on regular basis. This question was June in 2023 in the Northern Cape province. Okay, and the question say the following. Point B of negative 4 nanocoulomb is placed at a point. Draw the electric field pattern around point B. Now, point B is negative. So, to draw the pattern for point B, the first thing we have to do is to draw point B. So, here is B. And B is negative, so this is an isolated charge of negative 4 nanocoulomb. So now the lines, the electric field is represented with electric field lines. Those electric field lines are perpendicular towards the charge, straight line, and they must be perpendicular to the surface of the charge. Okay, so here is how you draw the electric field pattern for that specific charge. Okay, there we go. If instead of having a negative you have a positive charge, then the same drawing but the direction of the lines is out. And this one is question 6.1. there are 2 marks here. There you will get 1 mark for the direction and 1 mark for the shape. All right, so that is a very easy 2 marks. Question 6. The next question say point A and C of positive 2 and positive 5 nanocoulomb respectively are placed as shown in the diagram below. So now you have the following pattern with question with a point A that we already draw. And the question 6.2 say define the terms electrostatic force. Guys, and the electrostatic force is either the attractive or repulsive force between charges. That is the 2 marks there. Question 6.3 calculate the magnitude of the net electrostatic force on point A. Now we need to know what is going to happen to A due to B as well as C. So we are going to work first with B. What is B doing to A? And please don't get confused, we're working with A. Alright, so now A and B are attracting each other because B is negative and A is positive. So what is B doing to A is pulling it towards the right. So this here would be the force, which is B, force B on A. That is force B on A. Alright, because they is pulling A towards the right. Now what is C doing to A? You can see they are positive, the 2 of them, so they're going to push it away. So down here will be the force from C on A. Alright, so those are the 2 forces acting on A due to C and B. Now where is the resultant force here? Well, to do this one you have to draw the parallel line to each of them. This one is vector addition, and you will get that the resultant force is going to be from the point where they meet to this point where the lines are going to cut each other. This one is the net force or resultant electrostatic force, guys. That one is the one. And how we're going to calculate the magnitude of that electrostatic force? We are going to use Pythagoras. So F net is equal to FB on A, this one is a square, F net square is equal to FB on A square plus FC on A square. So guys, now all we have to do is to calculate the force B on A and C on A. Let's go to a new page to do that one real fast. Okay, let's start by the force B on A. How do we calculate this one? This one is K multiplied by QA, QB divided by the distance squared. Alright, all the information is given to us. The only thing is, remember, the charges are in nanocoulomb. We have to work in coulomb. You multiply by 10 to the minus 9. So this one is equal to 9 times 10 to the 9 times charge A. Let's go to the picture real fast. It's positive 10 nanocoulombs, so it's 10 times 10 to the minus 9 times charge B is going to be negative 4 nanocoulombs. Remember, do not substitute the sign in here. So it's 4 times 10 to the minus 9 divided by the distance, and the distance is going to be 0.07 meters square. There we go. And guys, the answer here is going to be 7.35 times 10 to the minus 5 Newton. Okay, so now let's go to do the force from C on A. All right, and it's the same formula, but now here we have CA, charge C, divided by the distance square. When we substitute, we get that the answer is 1.8 times 10 to the minus 4 Newton. Those are the forces. All we have to do is now to substitute those values in the Pythagoras to calculate the net force. We're going to do it also down here. Okay, so here we are. We're going to substitute all the numerical values here. And then we get that the final answer for the net force is equal to 1.94 times 10 to the minus 4 Newton. Guys, this is the answer. They ask you for magnitude, so we don't have to give the direction. The question is 5 marks, so let's quickly give the marks here. Okay, so you will get 1 mark for the Coulomb's law formula wherever you write it. 1, 2, and 3 for the substitution of these two calculation, 4 for the substitution in the Pythagoras formula, and 5 for the final answer. That is how we get in marks here. Guys, I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. We're going to mark the other question as well of an electric field strength, and I'll see you next time. Mr. G here.